Welcome to 2-3's video. Our lesson essential question is, can I perform a reflection on a coordinate plane? And can I construct a line of reflection? So to get started on page 117, we can consider the reflection of the left triangle. So that's going to be triangle FJD. And we're going to make it across the line M. And we're going to label the points F prime, J prime, and D prime. So F is itself, it's on the line of reflection, so it's not moving, F prime. And then the part of a reflection is that it's the same distance from the line of reflection that is then perpendicular to the line of reflection. So what I can do here is I can go J to the line of reflection, perpendicular, and then I can take that line, and I can then take the line, and I can, it's not moving the line, there we go, move the line there, and then my point would be right at the end of that there, and that would be J. And then I can look at this. It looks like D to the line of reflection is the same as J to the line of reflection, so I'm going to go there, and then I can mark my point there. So this would be my point D prime, and I should have put prime there. Then I can connect these dots, and it looks like that. So we've labeled it. Good. What are the relationships between J and J prime? So that's this, and D and D prime, and that's that. Well, those look like they are parallel. Moving on to page 118. We are now going to learn about the notation of a reflection. So you can write a reflection function in the form of capital R and then a subscript letter. That subscript letter is the line of reflection. And then P is the point you're reflecting, or in this case, of JFD, many points that form a triangle. So we're going to make the rule for what we just did. So we're going to have a capital R. Line we reflected over was M. And then I put parentheses, and I'm going to put down F, J, D. And then I'll put equals F prime, J prime, and D prime. Explain how your function represents the reflection of every point of triangle FJD. Well, if I recall, we had a triangle like this. Now, we did the endpoints of J prime, D prime, and F prime, but there's a point here and a point here. And those two are, in fact, a perpendicular same distance across the line of reflection. Same for this point here, and this point here, and this point here, and here, and this one, and this one. So it is a reflection of all corresponding points. And then describe the relationship between corresponding points of a reflection and the line of reflection. So the corresponding points are equidistant to the line of reflection. So part of this is understanding what it's asking. So looking at this, R is going to be my symbol clue that I'm reflecting. And this is saying to go over line M, and STUV is what I'm reflecting. So in class, we did, or we will do, how to do this with patty paper, but the distance from T to T prime would be the same after it goes to the line of reflection. So T to the line of reflection is the same as line of reflection to T. And then U to U prime, so it's going to be about right there. And then V is going to be about right there. And then S is going to be about right there. And then I can connect the dots. And it'll be that. For homework, it's going to be on Delta Math. You're not going to actually be drawing, and you're going to be able to count the spaces. What does this one mean? So this is going to be a reflection over the line C of points J, T, and G. So J would go to about right there. T is along the same one, so they go about right there. And G would be about right there. Connect my dots. Be sure to label them J prime, T prime, and G prime. Another part of what we're learning is how do I make a line of reflection when I'm giving two shapes? So by looking at this, I can probably assume the line of reflection is going to be about right there. And if in fact this distance from A to the line of reflection is the same as A prime to the line of reflection, and it is perpendicular, then it's the line of reflection. So what I need to be able to do is construct a perpendicular bisector. If I connect A and A prime, or I could do it with any two corresponding points, B and B prime, make the perpendicular bisector, then it will tell me where the line of reflection will be. So a brief recap on line of reflections. Let's connect those two. So we think this blue line is going to be the perpendicular bisector. How I would do that, I would get my compass tool out. I'd go at least halfway across. I make an arc, keeping the same distance, go to the other corresponding point, make an arc, and then yeah, I was pretty good. I extend that up, it goes through. So that's my perpendicular bisector. Other steps then. So connect two corresponding points, construct a perpendicular bisector. I did that on the previous slide. Connect the remaining corresponding points and label the points of each line segment with a perpendicular bisector. So if in fact I did B to B prime, they did A to A prime. If in fact though these three extras are the same, so B to N is the same as N to B prime, only need three, and then C to M and M to C prime are the same, this was a reflection. If it is not the same, and I can use a compass just to check the distance, if B to N is not the same as N to B, well then B would be like over here or something, or maybe the shape was tilted some after a reflection. So I just know that it has to be for all three. So if all three are the same, it is the line of reflection, and your perpendicular bisector is the line of reflection. If not, the figures are not reflections. So this just says that CM would be equal to C prime M, or C prime M, and BN equals B prime N. Part of our lesson essential question was, can I reflect on a coordinate plane? So if you're asked to reflect over a horizontal or vertical line, those are super easy. So this is the line of the y-axis. So that's going to be this line here. And I know that it will be perpendicular and the same distance. So when I want to reflect A over the axis, I count 1 unit, and I go then 1 unit, and I put down A prime. Then for B, I have 2 units, so I go 1, 2 units, lost my pen, 2, and I put B prime. And then for C, that would be 1, 2, 3, 4, 5. So I start and go 1, 2, 3, 4, 5. There's my point C prime, and then I can connect my dots. And it is a reflection of A, B, and C. The problem is that some of them are not over a line that's the same horizontal or vertical. So when you are encountered with one of these on Delta Math, it's very simple. We know the line of reflection and the line between the corresponding points has to be perpendicular. So I'm looking at this. Well, -3 is the line of reflection. The line that's perpendicular would need to be negative inverse of -3. So it's going to be 1/3. So I'm going to start at my point, and I'm going to go up 1/3, 1, 2, 3. And I made one full iteration. Then I'm going to go up 1/3 again and put a point. So this distance is up 1/3, and this distance is up 1/3. And since it's 1/3 and it's -3, I know that those are perpendicular. So go here, up 1/3, up 1/3, up 1 over, oh shoot. If I went up 1, I can't get to a full iteration. So I'm going to just go up 1/3, 1, 2, 3, and that was a half. Before I did that, I had 2 fulls. So I'm going to go up 1/3, up 1/3. So when it's a full iteration, I just complete and do 1 on the other side or 2 on the other side. If I do a half of an iteration, then I would just continue the half, and then I would do the rest of the fulls that I already did. So we'll go to this point, up 1/3. Okay, this is going to be another half, so I go up 1/3. That finishes my half. I did 1 before that, so I go up 1/3. And then there is my triangle that is hopefully going to be correct. Hey, I got the check mark. Good job, Mr. Heiderer. So, we just did that. So, your lesson essential question, once again, is can I perform a reflection on a coordinate plane and construct a line of reflection? I went over that in the video. For you guys to get really good at your practice, there's a Delta Math of 2-3, and then a Mathia called Describing a Reflection. And once you get really good at that, you come to me and do the lesson essential question check-in.